There are more people on Earth every day, and they all need to be fed. This means we have to increase the amount of agricultural production on the planet. But it also means that we have to increase the nitrogen fertilizers that are being used. This is leading to much larger emissions of gases such as nitrous oxide into the atmosphere. My name is David Miller, and I'm helping to coordinate a student-led independent project. Our team of 9 engineering graduate students are working to develop and deploy fast, compact, and low-power sensors based on a new technology, mid-infrared lasers. The main goal of MIRTHE is to build the next generation of environmental sensors. As part of MIRTHE's interest in new ideas and applications, the center provided a first-time opportunity for students to lead and manage a fully funded field research project. MIRTHE and its director, Professor Claire Gmachl, were extremely supportive of us. We design and engineer our sensors so that the laser can trace out a long path to increase the sensitivity of our measurements. To do this, we bounce the laser many times between 2 mirrors, which is known as a multi-pass optical cell. So this is the mid-infrared laser, the quantum cascade laser. The beam comes out through a lens here. The beam is directed by these mirrors through this hole into the sampling cell where the beam passes multiple times. The exit beam again goes through the hole and it's focused right onto the detector. We can see signals from nitrous oxide, acetylene, and carbon monoxide. Many kinds of human activities lead to the emissions of both greenhouse gases and air pollutants. We need to understand their impacts on both climate and air quality. We took our sensors into the field to a location between Washington, D.C. and Baltimore, Beltsville, Maryland, where there are both agricultural and urban activities. So we compared our measurements with a typical method, collaborating with the scientists from the USDA. We were really surprised that it worked the first time out. But normally when you're working with sensors, the first time it doesn't work out right away. This is exactly the engineering process. You know you have a problem to solve, but you don't know exactly how. So you try something. And even if it fails, you can usually see what it will take to make it work. We hope that one day our sensors will be able to measure trace gases on large scales so that people everywhere can understand their effects on the atmosphere.